Now let's talk about neural networks. And I want to talk about this because even though this idea was developed many decades ago, it's still a fundamental part of all the new technologies that have enabled generative AI. So the idea behind a neural network is a model that tries to recreate the way the human brain works. And the unit of this model is what is known as a node or as a neuron. So let's take a look inside of this node. First, let's start with the inputs. You can imagine this node as a mathematical function. And so, as any other functions, it takes an input. Let's imagine the input is going to be a vector with many elements. And these elements are going to be assigned weights, which is a coefficient that is going to be multiplied by each of the inputs. The product of these weights by the inputs are going to be aggregated, and there is going to be a threshold that determines whether this sum has passed the threshold. This is also known as a bias. Then the result of this aggregation is going to be passed to a function that is known as an activation function. This step enables neural networks to handle nonlinear problems. But this function, in its most simplest form, it could be just the identity function, which means it's basically passing the value without doing any transformation, right? And then this becomes the output of the node. So that's the unit of the neural network, just a mathematical function that is combining the products of multiple inputs. Now, when you combine multiple nodes, you create a layer. And these layers are also going to process the input. But the difference in this case is that all the inputs are going to be processed by all the nodes in parallel. Each node is going to produce an output. Now, when you combine layers, you create a neural network. In the simplest form, a neural network has only 3 layers: the input layer, the hidden layer, and the output layer. In a neural network, again, you receive an input, which is going to be a vector, and the results of every layer will be passed to the next layer. Finally, the output layer creates the output. So this is basically how neural networks work. Now, let's take a look how we train this neural network to do something that we want. So, we're going to start with input data. To train a neural network, typically you need to provide examples of what you're trying to predict. So you can imagine the input data as a data set, which each point combines or associates an input vector with a target value, right? And just to understand this a little bit better, you can imagine this input data as being applied in different fields. This, for example, could be customer data that is predicting the insurance risk, right? So you have demographical information about your customers, and you want to predict the risk associated to that customer. Another example could be business opportunities. You have information about the size of the opportunity or the customer or the product, and you want to determine what is the profit associated to that opportunity. Another example could be support cases. And if you want to predict escalations, you can collect data of your cases, like the priority, the product, the customer, and see based on this information, you can predict when a case is going to be escalated before it happens. Okay, so how do we train the neural network? Once we have our input data, we're going to feed this into our neural network. And remember, between the layers of a neural network are the weights, right? Remember those coefficients that are going to be multiplied to the elements of our vector. So initially, when you are starting to train your network, the weights are randomly selected. It could be anything. It doesn't matter, because the neural network is going to move from a random position in the solution space to the one of the places where one of the solutions exists. And so you start with the random values and you make a prediction. Now, because you have data, you can compare the quality of your prediction with the actual target. And so you compare that and you calculate an error. Now you know how bad was your prediction and what was your error. And using that error, you can send back this information to the weights in your neural network. And you adjust all the weights to minimize that error. Now, there's different techniques on how fast your model can learn. Sometimes you don't want your model to learn too fast because that can introduce biases. But the idea is that you repeat this process many times, hundreds, thousands of times, and eventually you reach the right combinations of weights that produce an optimal result. And voila, you have a neural network that can predict values based on input dataset. Now, as you can see, this neural network is going to be really good at predicting data for this particular problem. So one challenge the neural network have is that they are very specific to one particular problem space, right? And they're really good at what they do. But if the input changes over time or your targets move, then you will have to retrain your model.